Hello, this is Mr. Burgess, and we're talking about simplifying the expressions in this lesson. And what do we mean by that? Well, first of all, the reason why we're learning how to simplify expressions is because it's part of the equation solving process, the subject of this whole next unit. So it's really important. So let's move on to our next slide and see what we're talking about. So an expression is just something that looks like 4x plus 3 plus 7y minus 2x. Just some mathematical expression that has little terms in it that are describing something that we may be trying to figure out. And then they can come in all kinds of shapes and sizes. So let's see what we're talking about here. First of all, terms and expressions that have variables in them, like 2x, 5m, 7d, those are called variable terms. Terms that are just numbers themselves are called constant terms. Like terms are terms that just have the same variables, such as 6x, 2x, 10x, or if they just all had a's in them, something like that. And it also turns out that all constants are considered like terms, and so as we go along in this simplifying process, you're going to see that all constants can be collected together as well. So in our lesson, you're probably going to see a few problems like this where we give you an expression, a mathematical expression or algebraic expression, and we just see if you understand what it actually represents. So you're going to go through and answer all of these statements and tell us if they're true, or at least check off all the true statements. So we've got three terms here. They're all being added together. So the first statement says, if you have this expression, is it written as a product of three factors? And the answer is no, it's not a product because it's not being multiplied together, it's being added, which is what actually the second statement says. So we can actually put a little mark there saying that that one is a true statement. 9b and 1 are like terms. Well, they're not like terms. This first one's a variable term, and then the second one is a constant, so they're not like terms, so that's not true. 9 is a coefficient. Well, yes, 9 is in front of the v, so yes, that makes it a coefficient of v. 1 is a constant. 1 is a number all by itself up there in the expression, so yes, that is a constant. And since there were a few true statements up here, this last statement can't be true because it says none of the statements are true. All right, so let's keep moving. Here's another one where you got a little bigger and more complicated looking expression. But as we go through here, it might only be asking us about one particular part of it. So let's look. First one, in 7u, so in this first part right here, 7 is a coefficient. Well, yep, 7 is the number in front of a variable, so that's a true statement. Okay, in 7u plus 4, it is written as a sum of three terms. Well, it is written as a sum, but there's only two terms in there. If you look, 7u and 4, so not a sum of three terms. So that's not a true statement. X and 1 are like terms. Well, they both happen to be constants, so that would make them like terms. 7u is a factor. Well, 7u is not being multiplied by anything, so it's not a factor. And in 7u plus 4, 7u is a constant. No, can't be a constant because you have a variable, the letter u there. So these are the only two true statements up here. All right, so if we have a couple of expressions that do have the same variable in them, let's see what it would take to simplify them. So basically you gather them together by adding or subtracting. So negative 5 plus 3x would be negative 2x. Okay, on the next one, 6a plus 4a would be 10a. Make a better 10 than that. So 10a, and then plus 12 on the end. So that's all there is to simplifying these expressions. Okay, our next one, 12a minus 4 minus 3. Well, that's just going to be 12a, and it doesn't change because there's nothing to add or subtract to it. But these two constants can be combined, minus 4 minus 3, which makes it minus 7. Okay? What about 6y minus y? Well, if you ever have a variable by itself, just put a 1 in front of it. So 6y minus 1y would make this a 5y. And then negative 11a squared minus 14a squared, that's going to combine to give you negative 25a squared. All right, then the last one, negative 4c squared plus 9c squared equals 5c squared. And that's how that works, okay? All right, let's keep moving along here. What if we have one that's a little bigger and it has a's and b's and c's or whatever, but it also has other terms? Well, you'd combine the two or three that you have that are alike, and then you would put the other ones on the end, such as this one. 12a minus 4a would be 8a, and then you got a minus 4 on the end, so that would be the size of that one. This next one, negative 26 plus 14a plus 19 minus 48a. So this in this first set, negative 26 and 19 would be negative 7, and then 14a and negative 48a would combine to be negative 34a. And that's how you do these type of problems. What if they get even bigger? Well, the same process. You might have a little bit more to keep track of, so let's go through this one and take a look. So let's start out with the a terms, 5a and 4a. They're both positive. You combine them together, you get 9a. Okay, let's look at the b terms next. So 6b and 6b. If you put those together, combine them, you get 12b. And then after the b terms, you got one constant term, which is a 13. And it's positive, so you just put plus 13 on the end. And that's all there is to that. Okay? So let's try one more. Let's come down here and do number 4. Looks like the numbers are kind of big. So let's go back to our a terms, negative 29 and negative 45. So that's going to be 69, 70, 71, 72, 73, 74, negative 74a. Oftentimes I see students try to rattle these off in their head, but they're not understanding all of the rules that go along with it, and they end up missing it. So don't be afraid to use your calculator. So our b terms, negative 1b plus 19b, that's going to give us a grand total of 18b. And last but not least, we have our constant right there, which is plus 16. And we have indeed made this expression quite a bit more simple than it started out to be. Okay, and in some of these problems, we're going to have to do a little bit of distributing in order to simplify. And so to do that, you just multiply any number outside of parentheses by any number inside, and then write the results. So 2 times x would be 2x, and 2 times plus 3 would be plus 6. So there's one. Let's try a couple more. How about this one? 11 times u and 11 times 4. So 11 times u would be 11u, and 11 times minus 4 would be minus 44. Or 9 times 8, and then this one. 9 times 8 is 72, and 9 times minus 1w would be minus 9w. So that's how you do those kind of problems. You just multiply the number on the outside of the parenthesis by the number on the inside, even if the number happens to be on the back side, like this last one here. So 5 times 2x would be 10x. And 5 times minus 3 is minus 15. Multiply those three together, and you got that one. Okay, what if you have a little bit bigger problem? Let's do this last one, because it's got all of the elements of a little more difficult problem. Now, because this one has parentheses around it and no plus or minus sign in between, we know we're multiplying this negative 4 by all three terms on the inside of those parentheses. So negative 4 times negative 3 would be positive 12. Negative 4 times 6 would be negative 24y. And then lastly, negative 4 times that 1b there would be minus 4b. So that's the distributive property and getting rid of parentheses. Now in some cases, these terms actually have the same variable in them, and you have to do a little more simplifying, but for now, we haven't seen that in these. Okay, here's a couple more with the distributive property. So I'm going to do the middle one. 2 times 2 would be 4v. 2 times minus 5 would be minus 10. And we happen to have a minus 7v up on top. So, sorry, that's a v. So 4b minus 7b would be negative 3b. And minus 10 on the after that. And we like to write the v first because usually in mathematical notation, the variable term comes first. All right, in this case on these problems, there's actually two sets of parentheses, so it's a little more complicated. And as we get through or get into our little equation unit, some of the problems are going to have two sets of parentheses. So let's do one. Let's do this last one right here. So let's do the one up here. We have a minus sign in front of this first set of parentheses, so that really means minus 1 is out there. So negative 1 times y and negative 1 times 2 would be negative 1y, and negative 1 times 2 would be minus 2. Then in the second set of parentheses, 2 times 4y would be plus 8y, and 2 times minus 4 would be minus 8. So let's combine our like terms. We got minus 1y and 8y, which is 7y, and negative 2 and negative 8, which is negative 10. So that's how you do those particular type of problems. So there's your assignment. Number 9, simplifying expressions.